Supplemental math videos from Circle Christian School.
Factoring to solve for x. The roots, the zeros. The zero product rule equals 0. Why factor polynomial functions to its factors? Well, of course, to find the value of x. We call these the roots, the zeros, the x-intercepts. Another way to factor is what's called crisscross. It's may be very close to what Mrs. Carlson showed you. There's the one that's on the previous video on how to factor, and then there's this one. It's just very similar, but you may like this way a little bit better. The whole thing is to factor to look for the double bubble. We're taking it back to binomial form. Okay, so you make a little crisscross here. You put down your two numbers that you're looking for. For instance, a times c gives us the positive 30, and the b is a negative 11. So we're just kind of manually in our head think of different, look at the two numbers here that make 30, which is of course the 2 and the 15, a times c. And then we find those factors, which is going to be 6 and the 5, and making it appropriate for the sign, whether it's going to be negative or positive, put down the b. And that just lets us know what's going to be in the middle there, what I call FOIL form. And we break it up, factor by grouping, put the two groups down. After factoring the first group and the second group, we get x minus 3 and 2x minus the 5. Okay, now the reason why we factor is to go find x, the variable. We use the zero product rule. That is, all factors with a single variable equals 0. And so we factor to solve. That is, we just make everything equal 0. So given the basic quadratic equation, ax squared plus bx plus c, where a, b, and c is real numbers, we're just going to set it to 0. So we factor, and here I have an example of two factors, binomial times a binomial, x plus 4 and 3x plus 2 equals 0. We just set each one of the factors equal to 0. So x plus 4 equals 0, minus the 4 on both sides, and x equals negative 4. And then we take the other one, 3x minus 2 equals 0, subtract the 2 from both sides, bring down the 3x, and of course we have to divide everybody by a 3. And if you plug either answer back into the original equation, for instance, negative 4 plus 4 equals negative 12 plus 2, 0 times any number equals 0. Same goes for plugging in the negative 2 over 3. When we factor to solve for x, also known as the roots, the zeros, and the x-intercepts, what we're doing is showing a parabola and finding the x-intercepts. If it has an x-intercept, generally it has some sort of y-intercept. The deal is to, of course, just factor completely. Maybe you have to GC fit it a little bit and factor out as many common things as possible. Or it's a nice, easy one where a equals a positive 1, and it just gives us the double bubble, x minus 2 and x minus 4. And we're just going to set it to 0. By now, you may have found that there's a quick way for doing this, that x is going to equal the opposite sign and then the reciprocal. So x here is going to equal a positive 2 and a positive 4. That's the roots. Because the quadratic equation was positive, we know we got a smiley face. The plus 8 here is what the y-intercept is. And we can pretty much produce a quadratic equation here based on the fact that we know both sides are very symmetric. Okay, here's a few examples of factoring to solve quadratic equation where a, the leading coefficient, is not 1. And so we have 2x squared minus 5x minus a 12 equals 0 here. And we know we got to do a little bit of factor by grouping. I need to find factors for 2 times a negative 12, which is negative 24. That when we add them together, we get a negative 5. big number always carries the sign, and because it's a negative 24 and a negative 5 here, we know the 8's going to be the negative. So we take it back down to FOIL form here, factor by grouping, and then we take each of the factors and set it equal to 0. And again, in the first one here, we have a positive 3. The answer is always going to be an opposite sign, so a negative 3, and it's going to go over the first number, the 2, so negative 3 over 2, and x equals 4. The next one, x squared minus 9, is the difference of two squares. So x plus 3 and x minus 3, set those to 0, x equals a negative 3, and x equals 3. The next one is a smaller one. You'll notice we don't have a constant on the end. That is, we don't have a c. 2x squared minus 8x. And you always have to, when you have a leading coefficient that's not 1, the guy up front isn't a 1, we have to GC fit it. We have to see what we have to factor out. So we get 2x and x minus 4. Now, both of these are actually factors, the 2x and the x minus 4. We have to set both of them to 0. And solving for x in the first one, x equals 0. And solving for x in the second one, x equals 4. So our roots are at 0 and 4. And another special one is, again, we have to see if we can't JC fit it. That is, get out a greatest common factor, nothing common between the 4, 20, and 25. And these are probably the most difficult to see in a 5-second way. So you can always just factor by grouping, and eventually you get used to looking at them. But this is going to be a binomial square. You look up front, you look toward the back. See if you don't have perfect squares. And we do at 2x plus 5, which means x is at negative 5 over 2. And there's always two answers, and x at negative 5 over 2. So the parabola is going down to the x-axis here at negative 5, 2, and then going back up again from the negative 5 over 2. We call this a multiplicity when you have a same answer twice, or sometimes even 3 times. It's just a multiplicity of, we would say 1, which means one of the answers is being done twice. In real life situation here, we can use this for finding the area of a rectangle. What are the dimensions of a rectangle when the area equals x squared minus 3x plus 4? Well, again, what we want to do is find a real number for the x here. We factor to solve for x. So we know that length times width equals the area. So we have x squared minus 3x plus 4 equals the area. And in this case, we don't have a number for the area. If we did, we would just, again, set everything to 0. So setting it to 0, x equals the negative 1, and x equals the 4 after factoring. Okay, guys, look at the lesson forward to see how to go and do it. You'll see that it's pretty right up there. Goes with 5.5. Again, we factor and set it to 0 so that we can find out the possibilities for x.